In this tutorial, we're going to take a look at bias. So there's 4 kinds of bias we're going to talk about on the first page, and the first is response bias. Response bias occurs when there's some factors in the sampling method that influence the result. So for example, a reporter comes into the dressing room of a hockey team and asks them if they think they will win tomorrow. Now, most of the players would probably answer affirmatively or positively in front of their teammates, but they might answer differently if they were asked in private. Because of the fact that that question was asked in front of the whole team and maybe the coach too, they wouldn't want to say, "Oh, I think we might lose," actually, because that wouldn't be a very positive thing to say. So sometimes the way things are asked will influence the result. Okay, so that's response bias. Sampling bias is when the chosen sample does not accurately represent the population. So for example, let's say a person wants to know if people in the city are happy with the garbage disposal system. The person asks people on her street and all her friends, but this might easily not be representative of the whole city's residents. If the city had even 30 or 40,000 people in it, but all she did was ask a few dozen people, that's a pretty small sample. And so it's probably not going to give an accurate account of all the opinions of the people in the city. If you actually went around to the city and asked a certain number of people, like in different neighborhoods or different regions in the city, and everybody had a chance to have a say, then that sample would more accurately represent what the city's residents think. Measurement bias, when the sampling method over or underestimates some characteristics of the population. So a measurement bias occurs if you have some kind of measuring tool or technical tool that's not functioning properly or has not been calibrated properly, or if you're asking questions that don't allow for all possible answers, then that's measurement bias. Last one, non-response bias, is when the results are influenced because some surveys are not returned or all the questions are not answered. So let's say that a male survey has only an 8% response rate. The collected data probably isn't too representative of the whole population if only 8 people out of 100 returned it. So actually male surveys aren't a good way to collect data because the return rate is often so entirely low. In fact, another thing that confounds the problem is that a lot of the time, the only people that return them are the ones that feel really strongly about this particular topic. Maybe they're even upset or angry about it. So if you're only getting people that have some kind of a vested interest, then you're not getting what the whole population thinks about something. So that's non-response bias. So in this example here, you're asked to identify the type of bias. So a survey asking the following question, the new smelter will produce a number of high-paying jobs in the country. Are you in favor of this exciting project? So that would be response bias because this is a leading question. If it just said a survey asking the following question, are you in favor of this exciting smelter project? That would be okay. And actually, I stopped my thing here. There we go. The fact that you're saying the new smelter will produce a number of high-paying jobs in the country. So this is a leading question because those words at the beginning are meant to influence the person answering in the affirmative to get them to say yes. You should really just be asking, are you in favor of this project? Yes or no. Or even give a rating scale somewhere from completely disagree to completely agree. Next one, a survey using a cluster sample of Ontarians to determine whether the provincial government should fund a rapid train service between Hamilton and Ontario. Now, this would be sampling bias because your answer will depend on which cluster you sample, since the population is grouped on the basis of geography. You see, if we're only concerned about this rapid train service between Hamilton and Ontario, but you're sampling all of Ontarians, well, you probably shouldn't be asking people that might live 1,000 or more kilometers away. Okay, so that would be sampling bias. A last one here, a store includes surveys in their customers' bags for them to fill in and mail back to the company. So this would be non-response bias because not all the shoppers, in fact, again, mail survey, a lot of them will not return it. Okay, so that would be non-response bias because you might give out 1,000 surveys and maybe you only get 35 back. This is a YouTube link here to a video that's actually pretty good on talking about different kinds of bias. So that's something you could check out as well. I won't play it here though. So we're going to talk about misleading statistics in the last part of the tutorial here. And here's a graphic that is misleading. And the reason it's misleading is because the scale doesn't start at 0. It starts at 192,000 and goes up to, well, the top, this is actually at 200. The scale goes up to 201,000. So notice this one's actually at 195 and this one's at 200. So the way the graph is drawn, because it doesn't start at 0, it makes this bar look an awful lot bigger than this one. Now notice the numbers are quite large. They're around 200,000. So this bar actually is only 5,000 bigger than this one. If we were to graph the two of them with a scale starting at 0, they look like this. So you can tell that this bar, the 2014 one, is higher than this one, but I would use the word marginally higher, or words, to describe how much different that is than that one. And in fact, I put a rectangle around here. That rectangle is really what this graph is, because it's only showing you from about 100, just over 190,000 up. So this little bit right here and this bar, top here is actually what those two bars look like in the big picture, like with the scale starting at 0. So beware of scales that don't start at 0. They can be used to drop a bunch of the data out of your point of view so that what's left can look misleading. See, it actually looks like this bar is like more than double this one, when in fact it's only a slight amount larger. Now, beware also of when people use the words percentage change. Okay, so percentage change, the way you actually calculate it is you take the new value and subtract the old value, divide by the original value, and multiply it by 100. That's how you actually calculate percentage change. Now, here's an example. In this example, let's say some reading you're taking is at 10%, and you told it goes up 20%. Is the new value 30%? And it's not. If something goes up 20%, then that's a percentage of the original amount it goes up. So you would not add 10 and 20 to get 30. The way you would actually calculate that is you take the original amount and multiply it by now 0.20, or 0.2 is 20%, the equivalent decimal equivalent of 20%. So 10 times 0.2 is 2. So it would actually have gone up 2%. So we would take the original amount, add 2%, and it's 12. So if you have something at 10% and it goes up 20%, see, the 20% is actually just 2. It's 1/5 of the original amount. So the new reading would actually just be 12%. So be very careful of when people use percentages, because sometimes people use them in very non-mathematical ways that can be misleading. Okay, here's another common problem to look out for. Again, this is a scale thing, not too much different than the "Don't Trust Us" incorporated graph. So pay attention to the scale on graphs. And this, again, is similar to the one on the previous page. These two graphs show the same data. The scale here goes from 0 to 3,000, and the scale here only goes from 1,200 to 2,100. But you see, the graph is the whole bottom part is cut out. You see, this one actually has a scale goes down to 0, even though the first number is actually quite a bit over 1,000. In fact, it's about 1,300. But because this graph here is only showing the amount between about here and here, and it's stretched vertically, it makes the graph look a lot steeper. So if you want people to think that, oh yes, this data is increasing quickly, then that's the kind of misleading thing that you can do. Those two graphs actually are of the same data. Similar things been done here. The scale actually goes from 0 to 300, so this is actually a scale from 0 to 300, but this one actually started at 240. So same data actually. So this graph here is actually this graph about this much, just around here. So notice it goes from 250 up to almost 300. So this goes from 250 up to almost 300. But because of the way the scale has been changed, it looks like this one, the annual fees are increasing much more quickly than this one. You can tell they're increasing here, but this makes it look more dramatic. So some things to ask yourself when you see any kind of a survey, especially in the media. These are some questions you can ask to determine how valid that study is. Can accurate conclusions be drawn from it? So here's the first question. How were the people in the survey chosen? Is there some kind of sampling bias that might exist? Were they randomly selected? Was a whole segment of the population potentially excluded? Okay, so how were the people chosen? How many people were surveyed? Was the sample size large enough to be representative of the population? So for example, let's say the population was all of Canada, even just all adults in Canada. If they only went and asked, let's say 12 people, then that's a very small sample, and it's the way those 12 people think is very likely not to be representative of the way the whole population thinks. What questions were asked in the survey? Were they a valid assessment of a person's knowledge? What kind of questions were asked? Were the questions leading at all, designed to lead the respondent to express a particular point of view? And which group commissioned the survey and publicized its results? Okay, what is their agenda or mandate? For example, if you find that the survey was sponsored by some company that's trying to get their product out in front of Canadians, then maybe there's some kind of bias there as well. Okay, so if the survey was actually created by and ran by some company that has a vested interest in the results, then it might not be very accurate or reliable. So unless you can get satisfactory answers to those questions, it's always wise to remain skeptical about any kind of claims that survey might try to lead you to believe. And that's the end of the video.